Hey, all you cool cats and kittens. So, today we're going to be finishing up our kind of study of geometric sequences, and we're going to get into some geometric series here. And then, kind of the last part of the chapter that I've talked about, we'll get into probability a little bit. So, I'm going to go ahead and skip a lot of this stuff with arithmetic and all the formulas. On your quiz, you can use your notes. That you'll have at least all the formulas. That's what you'll be given. That's what you should use. So I'm going to skip a lot of the formula stuff there. Now, to refresh your memory on the difference between a sequence and a series when we talked about arithmetic, remember an arithmetic sequence would be something like, 4, 7, 10, 13, dot, dot, dot. It's going up by 3 every time. And then we said if we were talking about an arithmetic series, that's when we go ahead and add all of these terms together, and those commas get replaced with plus signs, and we end up getting an actual sum in the end. Same thing goes with geometric series. So a geometric sequence, to refresh your memory, is if you would have something like 2, 6, 18, 54, dot, 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 something that's going up by multiplication. Now, a geometric series is when we take all those terms, add them together, and get a sum. So a similar token to the arithmetic stuff. So the definition of a geometric series is the sum of the terms in a geometric sequence. We're going to learn 2 more formulas in this lesson, so I think that'll bring it to a total of 5. I think there was 2 arithmetic formulas, the sequence and the series, and then there was a geometric sequence formula, and there's going to be 2 for a geometric series, depending on what information you're given in the problem. So the formula, if I was in class, we would go through kind of a proof for this. I would show this, but I'm just going to give you the formula, and we're going to dive into some of the examples just to save some time. So here's our formula for adding the terms of a geometric sequence. The sum of n number of terms, which the problem will give you typically, or you might have to find it based on what they give you. But the sum of n number of terms, we take the first term times 1 minus r to the n power, r being the common ratio that you're multiplying by each time, n is the number of terms, divided by 1 minus r. So that's our formula right there. Nothing cancels. We can't cancel the 1 minus r's here because of this exponent. So this is the formula. When issues are made, it's typically in the calculator. So as we go through the examples, I'm going to set the problems up and basically give you the answers. But I would encourage you to enter it in your calculator yourself, because I find the concept of this is not very tough for students. It's mainly calculation errors, which are more frustrating than anything when you know what you're doing, but then you just type something in wrong. So I would encourage you to practice typing these in your calculator just to make sure that you are getting the same answers that I'm getting. So the first one says our first term is 16. It's going up we're multiplying by 1/2 every time, and there's 7 terms we want to find the sum of. Now we could just jump into the formula because the only things we need to use are the first term, r, and n, and we have all the information. But just to give you an idea of what we're doing, let's say you were taking some quiz, some test, and you were like, oh, shoot, I don't remember the formula. Let's say it wasn't given to you. Well, you could always write out the terms, right? The next term would be 8, and then 4, and then just keep multiplying by 1/2 till you get 7 terms and add them together. I mean, that's kind of the workaround. Keep in mind, if I said 70 terms, you're not going to want to do that, and that's why these formulas are beneficial. So let's use the formula. The sum of 7 terms is going to be the first term, so 16, times 1 minus, and then I'm always going to put r in parentheses. I'll explain why as we go through. I don't know if there's any examples on the notes where it truly matters, but I'll explain why here in a second. To the 7th power, all divided by 1 minus 1/2. It's 1 minus r. So it's a sub 1 times the quantity 1 minus r to the n, all divided by 1 minus r. So the reason I would put this one in parentheses right here is mainly if r is negative, let's say you were multiplying by negative 1/2 each time, and then if I take a negative number to an even exponent, this would actually become positive, and then we would have 1 minus that positive number. The biggest mistake students make is they'll put a minus here. Let's say this was negative, and then they'll think these two negatives become a positive, and they don't. You have to do the r to the exponent first, and you may get a negative number when you do that, but then you have to do 1 minus whatever that number is. So the parentheses there and the negatives are just things to be careful about. So if I were you, I would enter this in your calculator. Some students are able to enter it all at one time, and that's fine. I don't need to see like step by step what you're doing line by line. All I really need to see is you plugging in the numbers correctly, like this, and then I'm fine if you just put equals and then whatever it is. In this case, it's 31.75. I don't need to see anything other than that. I do need to see this step here. That's where you'll get your partial credit right there. I would not give you any credit if you just had the answer on a quiz or something. So make sure you're showing all the work. Now, again, pause it. I would type that in your calculator. If you're not getting the right answer, sometimes it's because when you're dividing by 1 minus 1/2, if you're trying to enter it all in the calculator, always make sure you put the whole denominator and entire numerator in parentheses in your calculator. That can cause some issues if you don't. I like to do it just bit by bit. Like in my calculator, I'll show you what I do while I have it here. So I like to do it piece by piece. I would do 1/2 to the 7th first. That's the first thing I would do. So I get that. And then it's 1 minus that. So 1 minus, and then a cool thing on the 84, you don't have to retype that number. You could just arrow up and push enter. That will avoid any rounding issues or like, if you retype the problem wrong or something. So I get that. So that's what is right here. Now it's that times 16. So times 16. This way I'm not rounding anything throughout the problem. So that, and then it's that divided by 1 minus 1/2. Typically, I just do that in my head, so I know it's just 1/2, so divided by 0.5. And then I get my answer that way. So I always do it bit by bit. I don't like to enter it all at once because I always find errors with parentheses and things. So there you go. B, find the sum of the first 6 terms. So we're adding 6 numbers together of the geometric sequence. So remember to use the formula. We need the first term. It's 1 minus r to the n divided by 1 minus r. So we need to know the first term. We know that's 4. We need to know r. So this is multiplying by 3 each time. And then we have to know how many we're adding. And it says 6. So I know all the info in this problem. So the sum of the first 6 is the first term times 1 minus r is 3 to the 6th, all divided by 1 minus r. Some students find it beneficial to like list the variables off to the side. That way you don't confuse them in the work. That's up to you. I don't need to see that. This is all I would need to see. And then whatever the answer is, again, I would make sure that you type this in your calculator. Make sure you get the answer of 1456. So if we added those 6 terms together, that would be our sum. Okay. Sometimes the problem directly tells you how many numbers you're adding together. But if I look at number 4, it says find the sum. We know the first term, we know the last term, and we know the common ratio. We don't know how many terms there are. Now, there's ways to find it. If you want to use the geometric sequence formula, you can. But since you would be solving for an exponent, you're going to have to use logs. Or you can use this other formula. So here's an alternative formula if you know the last term, but not necessarily how many you're adding. So here's just a different formula. So the sum is going to be a sub 1, so the first term, minus r times whatever the last term is. So it's the first term minus r times the last term divided by 1 minus r. So it's just a second formula based on the information the problem gives. So since I need the first term, r, and the last term, and that's what this problem gives me, I'm just going to go ahead and enter all that stuff in. So the sum is going to be whatever the first term is minus the ratio times the last term, which is 256, divided by 1 minus 4. And again, I would just go beep bop, beep bop, boop, equals 340. All right, 5. So in a certain geometric series, notice what they're telling us here. They're telling us that when we add 8 numbers together, our sum is 13,120. I don't know why that little space is there after the comma, but that's 13,120. So we know the sum of 8 numbers. It says r is 3. They want us to find the first term. Okay, so we have to make a decision which formula do we want to use. You know, we have two options. We have this one, and then the one we just learned up above right here. So we have to decide which one would be better for us to use. Well, a sub 1 shows up in both formulas, so that doesn't help. R shows up in both formulas. We know that. But let's think about the information they give here. They tell us we're adding 8 numbers together. We don't necessarily know the last one. So we're not going to be using this formula because we would have to know the last term, and we don't. We do know n, though. Indirectly, they're telling us n is 8. So we know the first term, or we're looking for it, I should say. We know r. We know n. And on this problem, we actually know the sum. Most problems, this is what we're trying to find, but this problem gives this to us, so we can fill that in with 13,120. So 13,120, that's our sum, equals a sub 1, which we don't know, times 1 minus 3 to the 8th, divided by 1 minus 3. And then you would just solve this for a sub 1. I'm not going to go through all the steps here, but this would be negative 2. So I would multiply both sides by negative 2, figure out what 1 minus 3 to the 8th is, and then divide both sides by it to get your answer. But the first term is quattro, 4. All right, just a couple more, and then you guys will get some practice. So anytime we're talking about series, arithmetic series, geometric series, this sigma notation pops up. It's probably, for a lot of students, the least favorite thing is this sigma, and so I tried with the arithmetic to really get you to understand it. I will say this shows that if you plan on taking like BC calculus, this shows up big time. This is kind of the big component in BC calculus versus AB calculus, is this idea of series and adding things together. So this is, like I said, the big topic. Okay, so for sigma notation with geometric series, here's kind of what this looks like. We draw our sigma, n equals 1 to however many numbers we're going to add together. And then it's just our general formula. It's our geometric sequence formula we talked about the other day, right here. So that's how we can pretty much recognize we're dealing with a geometric scenario, is if the thing inside the sigma, this expression, is not really linear, like a linear expression, like arithmetic, but you have an exponent and stuff like that. That's how you know it's going to be geometric. Okay. Now, we have a couple options on this problem. You could plug in 1 for n, then plug in 2 for n, then 3, then 4, then 5, and get your 5 numbers and add them up, and you get your answer. And I would fully be okay with that. The problem is, if this said 1 to 50 or something up here, if I made that a 5, 0, well then you're not going to want to expand out 50 terms and add them together. So since this is a geometric series, let's think about what we know, or what we need to find a sum using those formulas, right? You can actually use either one. You can use either formula. You can use the one, in either case, you need to know the first term and r. So in either case, you need to know those two things. you can see what the first term is by plugging whatever this bottom number is. It doesn't have to be a 1. It could be a 2 or a 3 or a 4 or whatever. But you find your first term by plugging this bottom number in for n and seeing what this expression is. So if I plug 1 in for n, I'd get 3 to the 0, which is 1, and then times 4. So the first term is 4. So I know that. R is just whatever is being raised, whatever number you have being raised to the exponent. You can see that right here. R is just this number. So in this case, R is 3. To use our formulas, we either need to know how many numbers we're adding, or we need to know the last term that we're adding. And you could find both pretty quickly, depending on the formula you want to use. Remember, if you want to figure out how many numbers you're adding, you take the difference between these. It's not just always necessarily this top number. It is if you're starting at 1 down here, but you don't have to start at 1, so be careful. You subtract these, and then add 1 to account for the bottom number. So 5 minus 1 is 4, and then add 1 to account for the first one. So we're adding 5 numbers together. So if this is the info we have, we'll use that first formula we learned in the notes. If you wanted to find the last term, just plug this top number in for n and see what the expression is, and then you can use the second formula we learned. So it's really up to you which formula or how you want to attack this. Basically, I just showed you 3 different ways to do this problem. So since this is the information I wrote, I'm going to use the first formula. So the sum of 5 numbers is the first term, so 4, times 1 minus r to the n, divided by 1 minus r. Notice I'm still putting that r in parentheses up here. I should have one on the notes where that's negative. I don't. But when that's a negative, that's where issues tend to come into play. But enter that, and you get 484 right there. Okay. Last one. So they give us this second term. They give us the fifth term, and they tell us we want to add 8 numbers together. Okay. So I want to add 8 numbers together. We don't know the first term, and we don't know r. We don't know either of those things, so we have to find some information here, okay? So when we did arithmetic series, oftentimes we would have to use the arithmetic sequence formula in the middle of the work. We got to do the same thing here. Let's pretend for now that this is the first term. It's not. Keep in mind, here's basically what we have. We have some first term, 250, third term, fourth term, the fifth term, 16, and then we have the 6th, the 7th, and the 8th. And we want to add all these numbers together, right? So for now, let's just pretend like this is the first term, and this is the last term of this little mini sequence right here. And in doing that, we can find r. We can use our geometric sequence formula right there. We can use that, and we can find what r is. In this little mini sequence, we know the last term is 16. We know the first term is 250. We don't know what r is, but in this little mini sequence, there are 4 terms. N is 4. So 4 minus 1 is 3. So we can use this information, and now we could solve for r. I don't like decimals. You guys know that by now. So, if I want to keep this in terms of fractions, we could divide by 250, which is, if you reduce, 8 over 125. And then we can cube root both sides. So the cube root at the top and the bottom, r is 2/5. Right there. That means that this sequence is being multiplied by 2/5 as we keep going. What that helps us figure out is the first term. If going from left to right, we're multiplying by 2/5, then from going from right to left, if we want to go backwards, we're dividing by 2/5. So if in your calculator you do 250 divided by 2/5, you get 625. That's the first term right here. And now we know the first term right here. We know how many numbers we're adding, and we know what r is. So we can use that formula, the very first formula that we learned. So the sum of 8 numbers is going to be the first term times 1 minus r to the n, which is 8 in this case, divided by 1 minus r. Again, I would just highly encourage you to enter this into your calculator and make sure you get the right answer. You're going to hate yourself, not hate yourself. You're going to be mad at yourself if you do this right, type it in your calculator wrong, get the wrong answer. So you end up getting 1040.984 from your calculator. The last thing I wanted to add is, what if they give you, I'm going to kind of add one example here. That way, if it shows up on your quiz, you have this on your notes. What if they give you a series and they ask you to write it in sigma notation? So we worked on that with arithmetic. Let's talk about if you have a geometric case here. So if I want to write this in sigma notation, I'm not looking for the sum, but if I want to write this in sigma notation, that's the question. Remember, we always start by drawing the sigma. When they give you the problem, they don't have to start at 1 down here, so be careful for that. But if you're writing it, I would always start with 1. It makes the problems so much easier when you start with 1 always, because that means the top number is just however many you're adding. In this case, it says we're adding 12 numbers together. So when you start at 1, it makes it a whole lot easier. The only other thing we need to put is the formula inside the sigma. And that's just modeled by this. We basically just write this inside the sigma. What we need is the first term and r. We leave n alone. N is kind of the thing we would be plugging numbers into. We just got to find the first term and r. Okay, well, the first term is 3. R is whatever we're multiplying by each time. And if you're struggling to find that, just take the second term divided by the first term, and that'll find your ratio. So 2 divided by 3 is 2/3. And then to the n minus 1. And there it is. And you could verify that. Like if you plug 1 in for n, you should get 3. If you plug 2 in for n, you should get 2, and so on. So you can kind of check your work there. So there you go. That's kind of the end of the geometric stuff. And let me know if you have any questions at all.